Hi, mathematicians. In this mini lesson, we're going to refresh your knowledge of expressions. What I'd love for you to do is first pause me and brainstorm everything you know about expressions and maybe start in your math journal some notes for yourself. All right, hopefully you've had a chance to think. Here are some key things about what makes an expression an expression. I have two examples for you to look up here. First, one of the most important things about expressions is there's no equal sign in an expression, because the main purpose of an expression is to describe a pattern. So it describes a pattern. All right, so if equal signs can't be in expressions, what can be in expressions? And they can have really four basic things. Of course, they can have numbers. They can have variables. What else might they have? That's right, they can have operations, addition, subtraction, multiplication, etc. And then they can also have grouping symbols like brackets, parentheses, like that. Okay, so those are the components that can make up an expression. When we think about the actions that we can take with an expression, I think of three things. And we'll talk about each one. I think evaluate, so I'm thinking about action or verbs. Evaluate, simplify, and substitute. Evaluate is just a fancy way that mathematicians say, do the arithmetic. So if we have a little expression, 3 times 2 plus 6, evaluate means do the math. Now these equal signs I'm putting on the side are part of communication. They're just saying that each line is equal to the previous line. They're not really part of the expression itself. All right, the next verb or action that we can do is we can simplify. We love to simplify expressions. One of the main reasons is a simplified expression is so much easier to work with. So for example, here's an expression, 4 times the quantity x minus 3. To simplify that expression, I'm going to distribute. I have 4 x's and subtracting 4 3's. So 4x minus 12 is simplified. And then the next verb or action we can do with expressions is we can substitute. And here we would have a variable expression, maybe 2x minus 6, and we want to set the variable equal to -2. So this gives us a general pattern. Let's substitute -2 for x. That's going to be 2 times -2 minus 6. I should have put my equal signs there as well. -4 minus 6, which is equal to -10. Notice once we substitute the value for the variable, we're just evaluating. All right, so those are our basic verbs. Next, we're going to talk about how do you know when an expression is fully simplified. All right, I have another example here of an expression that is not simplified. So pause me and take a minute to brainstorm. How do you know, maybe a little checklist of what would you need to do to make an expression fully simplified? Pause me and then come back after you've had a chance to think. All right, welcome back. So I think about four things when I think about how do we know when an expression is fully simplified. So the first thing is that there are no grouping symbols. And these would be things like parentheses, brackets, grouping symbols. All right, so fully simplified, no grouping symbols. The next thing is that any arithmetic has been performed. So all arithmetic performed. Right, that's number 2. The next one is that all of your like terms are combined. And we'll talk about each of these in that little example. And I'm going to pause here for a minute and talk a little bit of like terms. So like terms, and we'll kind of do a little squiggle and come over here. For two terms, and terms are, remember, things that are being added. So we're going to be thinking about addition when we're thinking about terms. So terms, like terms, are things that have the exact same variables. Let's look at some that are and aren't. All right, 3x and 6x. Are they like terms? Yes, exactly the same variable x. What about 3x and 6x squared? Nope, because one variable is an x and the other variable is an x squared. What about 3x squared and 6x squared? Yes, because both of the variables are x squared. Let's do one more, 3x and 6xy. No. Even though they both have an x, notice the 6 also has a y in that term. Okay, so a little bit about like terms there. And then the very last thing to be fully simplified is we say no double signs. And I'll give you a little example of that. Sometimes we like to be working in addition, and so we might have an expression that looks like this, 3x plus a negative 2. So that's a double sign, and here we're going to take that and rewrite that as subtraction, because adding a negative number is the same as subtracting a positive number, and it would come down to that. All right, lastly, we're going to just work through an example together. All right, let's go through the checklist. No grouping symbols. We got some grouping symbols. So the best way to get rid of grouping symbols is to use the distributive property. So this is the same as negative 2 minus 6x plus, I've got 2 of each of the terms inside the parentheses. So I'm adding 2 x's and I'm adding 2 16s. All right, great. All arithmetic performed. Let's see, I've got a negative 2. Here, I'm going to first change my subtraction to addition. Subtracting 6x is the same as adding negative 6x. Some mathematicians like to do this. Some don't. Mathematician's choice. I like this because then in my head I can move all those terms around in any order. All right, so arithmetic, I know I can add negative 2 plus a 16. So that will leave me with negative 6x plus 2x plus 14, because negative 2 plus 16 is 14. Like terms, I've got some like terms here, the exact same variables. So negative 6x plus 2x is negative 4x plus 14. See, double signs, I don't have any double signs, so I'm fully simplified there. All right, mathematicians, that was a super quick refresher about expressions. In our next class, we're going to be working a lot more with expressions, and if you have questions, it'll be a great time to ask them, and we'll also be doing a lot of simplifying of expressions. All right, see you then. Bye-bye.